video lecture, we are going to discuss the topic called the bus expansion buses, the PCI bus, SCSI bus, USB bus, which is the expanded bus from the memory bus or processor bus. So those buses are have some special characteristics. So those buses, memory bus and processor bus, basically designed for the data control between the processor and the memory and some devices. So those are basically fast, and those are maybe carry less amount of data. So those bus cannot expand for the other device need to be connected. Maybe disk controller, maybe a scanner controller, maybe some the printer controller, the n number of printers we want to connect. So those devices need to be connected through the bus. That is maybe quite costlier. So that's why there is a industry standard bus have been developed. So that is like ISA from IBM. So PCI, SCSI and USB, which is developed by many group of industry, maybe Hewlett Packard and various other companies. So this topic we are going to be discuss now. The at the beginning I am going to discuss the PCI bus, that is a peripheral connect internet, the interconnect component, peripheral component interconnect. So the bus will be created during 92. And it is a obviously low cost bus, that is. So this is a processor independent. It is independent of the processor. So it's going to be plug and play. So plug and play. So whenever we need, so that we need to be insert that and play that, we make use that is. So that is a kind of mechanism will be there. So the plug and play. The recent days most memory transfer take in a burst of data. So we have discussed in the previous topic, that is especially DMA controller. So DMA controller, there is a bulk amount of data transfer between the devices or processor to device, vice versa. So there that is a intervention of the processor is very less there, right? So other than the DMA transfer, so intervention or involvement of the processor is a very high. So in order to avoid that, the less intervention, the involvement from the processor side, so that is a DMA. So DMA will be transfer the data in the two manner, either burst mode or block mode. So block mode will be transfer the huge amount of data, maybe 12 bytes, so on, that is. Burst mode may be 4 byte or 8 byte, like that. At in a single clock pulse, so this much amount of data will be take place. So today's technology, it supports for most of the memory concepts will be transfer only few bytes of data. So then just one word. So the peripheral interconnect, that is a component interconnect, is designed primarily to carry this mode of operation, such as burst mode data transfer, as we discussed in the DMA controller. So bus supports 3 independent address space. What is a bus? Bus is a collection of wires which carries the data, address and control information. So here in the PCI, the bus supports 3 such kind of activities. One, memory operation. So other, IO identification, input output, printer, keyboard, scanner, so on, that is, and configuration. Those through the ports, those devices we need to be configured. Those devices we need to be adjust to or follow the protocols as per the transfer will be happening. So that is a configuration will be essential. So that will be performed by that the independent bus called PCI. The master maintains the address information on the bus until the data transfer is done. So we have discussed in length also in the previous case. What will happen? The master transmits the data to the client or slave, right? So master transmit, that is. So slave, since it is an electromechanical device, it may be relatively a lesser speed, right? So that because electromechanical component will be involved, that the lesser speed. In other words, go to the very closer discussion. So data will be transmitted to the slaves. At the receiving side, slaves have a buffer. So that data will be there in the buffer till that slave has to download the data to in his premises. Till that time it is there in the bus buffer, right? So for which what we maintain, master maintains the address information of the clients in the bus till the transmission will be completed. So that is a meaning of that. But the address is needed only long enough for the slave to be selected. So address is needed for the long enough that is slave has to be selected. Thus, however, address is needed on the bus for one clock cycle only. So as a theory tells, most of the today's technology tells that they are very fast using the load store instruction or general purpose machines. So they are basically fast. So this operation should complete within one clock cycle. But in order to complete this within one clock cycle, how we can synchronize, how we can make up that speed of the clients or slaves or receiving end devices. So preing the address line to be used for sending the data in the subsequent clock cycles. So that data will be maintained at the receiving end buffer till the thinking that the slaves or the receiving end they are slow. So that why they wanted to maintain there to complete it in the remaining part in the subsequent clock cycle. So that is the meaning they are going to tell. The result is a significant cost reduction. The one clock cycle is dedicated to complete all this operation till from the master to the slave, so that significant cost reduction may be possible. If not, then you have to make use the part of the next clock cycle, so cost will be increases in terms of the time, in terms of the speed, in terms of the processor communicate with the real world. The master is called initiator in a PCI terminology. Addressed device that responds to read and write commands is called a target. Target is a slave, that is a receiving end. So initiator at the sending end. So sending and receiving, the initiator and target, master and the slave. The master are the clients, so or the server and the desktop system, or the desktop system or some printer. So like that the hierarchy will be there. So that will be a initiator and the target will be there. So considering this PCI bus, so here you can observe from this diagram. So these green slots are dedicated to insert the PCI bus, right? PCI bus. So there are 7 slots are there, 1 2 3 so on. That is one PCI E3 into 16, right? So 16 that is one PCI card slot will be there. So here we can plug that PCI card and play. Similarly here we have PCI 4. So PCI 4, so this is also one slot. It can, and also this is also one slot. So these slots are there in the motherboard. There you can insert the PCI card, right? So once the insert that PCI card, it establishes the communication between the processor and other devices. So here we can see some examples. For example, 32-bit card. 32-bit card of 5 volts, right? So this we can insert into the PCI slot. So also we can have 3.3 volts 32-bit PCI slot. So that is a 5 volt slot, 5 volt card and 3.3 card volt card. So that is a universal card also will be there. That is 3.5 and 5 32-bit PCI card. So 5 volt 32 and 3.3 32-bit card will be there. So this corresponding slots for this facing up, that is so this we can insert. So this will be black, and here we can see in a green color. So there similarly we have 64-bit PCI slot, right? For example, the Windows 10 operating system is a 64-bit operating system. So for such we need the Windows 7 is 32-bit. So for such we need a PCI 32-bit card. So here we need a 64-bit card. The 5 volt and 3.3 volt, that depends upon that architecture you need to select. So again this is universal, the universal one. that is 3.3 or 5 volt dual capability of 64 PCI card will be there. For 5 volt 64 bit card will be there. So the corresponding slots will be there. So from this diagram we can understand the industry, the potentiality, or if you open the computer, so there in the motherboard there are several slots are there. So there some certain slots are dedicated to this PCI bus, right? So I hope from this diagram we can able to appreciate the concept of the PCA. We'll move further to understand that is. So the PCI bus, we can see that. So PCI, we have a switch. So there is a bus will be there, sending bus and receiving bus. So bus will be there. So here port will be there, port. So we can plug, that is. So there is a one lane will be there. So 1 bit per cycle, data will be transferred 1 bit per cycle, the transfer rate, that is a PCI card. So coming to the double, the 2 lanes will be there. So 2 buses going and 2 buses coming back through the switch. So that is a 2 bit per clocks, that is the transfer rate, correct? So similarly the 12 lanes will be there. 12 lines are going and 12 lines are coming. So that is the 12 bit per cycle will be happening. So this is a multiple bit mechanism transmission happening through these links and lines, that PCI Express. So one more, that is a PCI Express comparison. So PCI Express serial connection. We have the bus chip, that is the buses are going and down. So this we can project in a 3 dimension, that is a switch. From this there is buses are going instead of earlier we said the connector. So now we can say device, 2 devices are connected. The PCI bus connected to 2 device 1, device 2. So the buses going and coming back. So similarly 3 devices are connected to the bus. So there is a parallel connection. Earlier one, that serial connection. So we'll see in subsequent discussion serial and parallel. Also we discuss in the previous discussion in the video lecture of this previous part, that interfacing circuit. There we discuss the serial and parallel ports. So we have 3 devices are connected. Here 3 plus 3, 6 bus, 3 buses going to each device individually, and 3 buses coming back individually to the report, that is a switch. So that is a kind of mechanism there. So coming to the signal transmission between the PCI controller and the other devices. So there is a different type of the activities through the clock, based on the clock. So clock will be there. So clock, we have 33 megahertz clock or 66 megahertz clock will be employed. The frames is that image of that data sent by initiate to indicate the duration of the transaction. So transaction duration will be initiated. So that is address lines. 32-bit address lines will be there, which may be optionally increased to 64-bit. So because this PCI bus connected to several devices, right? For example, consider an example, the 8 devices are connected to this bus. Again, this PCI bus connected to the processor bus or the memory bus, right? So in that case, what will happen? PC have 8. In order to identify each device uniquely, then 3 bit is required. 3 bit is required to identify 8 devices. Similarly, 4 bit is there, 16 devices we can identify. Similarly, the 32 address lines are there, 2 power 32, those number of devices we can uniquely identify. So those number of devices we can connect to this PCI bus. So from the address we can understand. See, control and this is a enabling, byte enabling. There is a 4 command bar byte enabling 8 for 64 bit bus, that is. So we have IRDY, that is a initiate ready signal. TRDY, that is a target ready signal. Initiator ready and target ready signals. So in other words, we can also call in the previous discussion we said that is a master ready and the slaves ready are also called IRDY. And slave ready is a TRDY, right? So that control signals will be transfers. So device select, that is a response from the device indicating that it has recognize the address and ready for data transfer transactions. So the device has sent the processor has that PCI bus has some address for the to identify the device selection. So the with help of that address, that is a 32 bit and so on, that is it will uniquely identify those device which devices requested the service. So that will be happening. So ready for the data. So the ID select, that is initialize the device select. So we need to be initialize those devices. Several devices are there. So those device we need to be initialized through the configuration. So the read operation on the PCI bus will be happening. So there are 7 clocks pulse will be make use to discuss this read operation with the PCI bus. So we have a frames is a complete image of the data, it is going on. So it is negated during the first clock, complemented the first clock pulse, and it is become normal at the 5th clock pulse. So during that time the data is active. So the along with that address will be sent where they have to write. So address will be encoded, and from the 3rd clock onwards that address will be byte 1 up to address, byte 2 of address, byte 3 of address, byte 4 of address. There is a 4 byte of address. So that 2 bit address will be there. It will be completely decoded and complete data is address data is available. So that is a control the connect command and the enabling byte enabling will be there. So command will be decoded and complete meaning will be available at the half of the 2nd clock pulse, and it is a byte enable is ready from 2nd clock pulse onwards till it is available beginning of the 7th clock pulse. So the initiator ready during what? So after end of the 2nd clock pulse, initiator is ready. So and we have also device select is also ready by end of the beginning of the 2nd clock pulse. Target ready at the as soon as that initiator ready. So this kind of configuration will be happening for the PCI bus. So when IO device is connected to the PCI, several actions are needed to configure both the device and software that talks with it. So PCI incorporates in each IO device interface a small configuration read-only memory that stores the information about the device. The configuration read-only memory of all devices are accessible in the configuration address space. So through the configuration address space we can identify them. So PCI initialize the software reads these read-only memories, that is frames, and decides whether it is the device is a printer, scanner or interface card, etc. It can further learn about various device options and those characteristics. Devices are assigned addresses during the initialization process, right? Initialization process. This means that during the bus configuration operation, device cannot be accessed based on the address. So that during configuration that is a dilemma will be there. So inconsistency of the address will be there. So that will be not there, as they have not yet been assigned one, and during configuration will be it is in catastrophic mode. So hence it may not possible to do so. It is specific job has to be assigned to the device with a particular its own ID, then it will be obliged. Hence the configuration address space uses a different mechanism. Each device has an input signal called initialization, device select, that is ID select. So those configurations signals will be there. Also the electrical characteristics will be there. So PCI bus has been defined for operation with 5 volts or 3.35 volts power supply. We seen in the previous diagram, that is slots or the card, PCI card, universal card, and that too 32-bit card and 64-bit card. In each card they have universal 3.55 volt. The standard cards are available in the industry, in the market, so we can make use of them. So after discussing that PCI bus which is going to be connect to various devices, so now in the similar line the one more expansion of the bus, that is called small computer system interface. That is a SCSI bus. Normally the people will call it as a SCSI bus. So small computer system interface. There is a one diagram is given here. So you can think that is there is a external bus will be there, and disks, n number of disks will be there, and at the end the scanner will be connected. So the scanner is a terminated. Terminated means from scanner onwards the no device is allowed. So it is the terminated will be wind up, and all these devices are connected in a daisy chain fashion. So in the serial fashion they connected. Similarly, the other set of device will be connected through the internal bus. So this is external bus. Through the USB you can also connect. So there is internal bus will be there, so that we can connect that is. So this is a host of the SCSI controller card that will be there. So it refers to a standard bus defined by an ANSI under the designation X3.131. ANSI is the American National Standard Institute. So their people are the pioneer people like IEEE, ACM. So these people are there to provide a benefit to the customer, benefit to the user. So otherwise what will happen, the industry people who are making electronics equipments, so they will make their own size and all those. So we have to fall behind them to buy the particular product. So if you possible to generalize, so one such the effort by ANSI under this X3 1.131 is made, that is. In the original specification, standard device such as the disks are connected to computer via 50 wire cable. So this is a standard. So length up to 25 meters. So that the SCSI bus will have up to 25 meters. You can imagine that your personal computer motherboard. So how many centimeters will be there? So that will be dealt in some of the meters. So even he can have that external bus. External bus. That external bus we can have up to 25 meters. Can transfer the data up to 5 Mbps per second. So the SCSI bus standard has undergone many revisions, of course. There is a SCSI 2, SCSI 1, SCSI 3. There is several versions will be there, almost doubling every year. That is defined each several options because various options SCSI connector may be 50, 60 or 70 or 80 pins. So why they are telling so that is 50 pins will be there, 68 pins will be there. For given a chip, the number of pins more, than it required a more power supply. It required a more supply, then cooling will be required. So that's why the more number of pins will be there, then it will be a quite electromechanical kind of device will become, that is. So power supply will be there, and that cooling will be required. So on, that is one and each other connected. So that one example from the industry, I taken the diagram from the internet. So we have the complete motherboard. So there we have a SCSI bus. So their devices are connected, hard disk and the other key, any other printer or scanner connected. So those who can connect, that is SCSI terminator. The last device which is there, as we said in the previous slide, that is a scanner. So last one we need to be terminate. We need to be stop to connect that. So the quick release will be there. So there is a bus and several devices will be connected. The last device supposed to be terminate. So here the same example we repeated. That is a SCSI host adapter. So adapter will be there. So that external chain, that is up to 25 meters length we can have. So scanner is the last one that will be terminated, and others will be non-terminated. They need to be interact with the other that one. There is a hard disk, a number of hard disk. So last device in the both internal and external chain must be terminated. So these are the one examples of this SCSI bus. So device linked to SCSI bus are not part of the address space of the processor. So the SCSI it is not the job of the processor. So processor will be given to some response to other like DMA we discussed. So the SCSI also have controller. It will take their those devices which are connected to this SCSI bus, and also we discussed the bridge. Bridge will take and help. It will responsibility to transfer the language, whatever the data or commands to the processor from either side, bus side. SCSI bus is joined to the processor bus through the SCSI controller as a DMA transfer, data packets from main memory to device or vice versa. So that will happen. The packet contain the block of data commands from the processor to the device, status information of the device. So controller connected to a SCSI bus is one of two types: initiator or target, master or the slave. So initiator has an ability to select the exact target which you are interested, to send a command specifying the operation to be performed, right? So that will be have the essential to select the which target they want to communicate. The disk controller operates as a target. It carries out the commands it receives from the initiator, that is a master. The master establishes the logical linking with the decided the slave, that is target. After link has been proven or confirmed, it can be hold and restore as needed to transfer the commands and burst of data. Once it is decided and identified, it can transfer and become a bus master, hold that is, and after completion it restore the whatever the necessary information they are disturbed in the burst of data. While exact link is on the hold, the other device can use the bus to transfer the information. SCSI bus. This ability to overlap data transfer requires one of the key features of the SCSI bus that leads to its high performance. So data transfer of the SCSI bus are always controlled by the target controller. So target controller, that is a slave, will be there to provide the data. So to send a command to target, an initiator requests the control of the bus after winning the arbitration. So select the controller to communicate and hands control bus over to it. Hand over to control of the bus over to it. So then controller starts a data transfer operation to receive a command from the initiator. So the processor command to SCSI controller. Example, processor need a block of data from the disk drive. Processor wants some data from the disk drive. Data are stored in a disk sector that are not contiguous. Consider an example. In order to perform this task, by providing some command to the SCSI controller, so processor wants some data which is not in the contiguous, it is not in the sequence. So that is stored in a scattered way in the memory. So that is not in the joint location, that they are disjoint locations. The processor sends the commands to SCSI controller, which causes the following sequence to be happen. So SCSI controller acting as an initiator here, right? So earlier the processor become our master. So now SCSI controller itself become initiator because it obey the order of the processor which assigns some task to the SCSI controller. Under SCSI controller, several devices will be there, content for the control of the bus. When the initiator wins the arbitration process, because several controller will be there in a system. In a system, SCSI controller will be there, PCI controller will be there, USB controller will be there, and DMA controller will be there. So several controls are there in the premise of the CPU. So those are all competing for to get the bus ownership. Similarly, bus control also has to be participate in the bus arbitration, has to win. After winning, that is, it become bus matters. Then when the initiator arbiter process, it selects the target controller and hand over the control to the bus to it. So similarly, the processor given a opportunity to SCSI controller. Similarly, SCSI controller will be given opportunity to target controller, right? So this handing over the responsibility to the lower level from processor to the target level. So hands over to control to the bus to it. so it can send the data. So target start operation from the initiator to target, it responds to this. Initiator sends a commands telling the required read operation, So target realize that the need of read, that is a read from the disk. So where it is the condition was given, it is a not contiguous, it is not in the sequence, or it not in the joint, it is a joint or the scattered over in the memory. That's why disk seeks operation sends the message to the initiator indicating that it will be temporarily suspend to the link between them. So then it release the bus. So the target controller sends the command to the disk drive to move the read head to first sector, right? Because it didn't read from there, so the read head will be sent to the first sector. Under the guidance of the target controller, disk controller will be performed that involved in the request read operation. Because it is guided by the assigned by the what is processor and SCSI controller. Enter now the target controller. So it taking the help of these people. So it initiates the read operation, then reads the stored it into the sector, stored it in the buffer. So from the particular sector, the data coming out after reading the properly, and it stored in a buffer. When it ready to begin transfer the data to the initiator, target requests the control of the bus. So after it wins the arbitration, again the same processor, everybody has to compete for the bus. So that several targets are connected to the one SCSI controller, right? So it wins that situation. It reselects the initiator control, thus restoring the suspended link. So this mechanism will be happening. Continuation of this, we can have the processor command to the controller, that is a target transfer the content to data buffer to the initiator and suspends the link again. So the target controller sends the command to the disk drive to perform another seek operation. One sector is over, it going to be next sector, because this non-contiguous way, that is. So again has to request that is a disk controller. Then it transfers the content to the second disk sector to initiate the, as we did earlier. At the end of this transfer, the logical link between the two controller is completed. It is nowhere is required. As the initiator control receives the data, as the condition play down, that is different sectors from the data we have to bring, that has done by this target controller. It store them into the main memory using DMA approach. The SCSI controller sends the interrupt to the processor saying that requested operation has been completed. So these are the sequence number of steps will be happened when the processor puts some assignment to this different controller. One such controller we have discussed, the SCSI controller. Operation of this SCSI bus from hardware point of view, the bus signals will be there. So we have seen in the singular case in PCI, so that signals will be there. So here that is a data and that is a DB0 to DB7. Data lines carry 1 byte information. During information transfer phase, identify the device during arbitration and selection, reselect the phases. There is a parity bit for checking the data, whether the data has reached correctly or not. For which we have to one method is checking the parity phase, that is a busy line, and select line. Busy, that declares when the bus is not free. Selection asserting during the selection of the reselection. Information types are there: control, data enabling, and asserting declare transfer information. Message indicates the information being transferred is a message. So the completion, as we discussed, the target controller has informed to the what is a SCSI controller has informed to the processor saying after completion of all the data transfer from the identified sector from the disk, right? So like that the end message there to be start message has to be need. So like that the messages are sending in order to have a that communication, proper communication. So SCSI bus signals will be there, handshake signals. So we have seen in the asynchronous mechanism, so that handshaking will be there. So there is a request asserted by the target to request a data transfer cycle. Acknowledgement will be there. So proper communication will be, smooth communication will be there. Acknowledgement, that is a part of the handshaking asserted by the initiator when it has completed the data transfer operation. The direction of the data that we have seen, the DDR, data direction register, one such direction whether from process to IO or IO to IO or IO to processor, the directions will be indicating. There is a ATN, attention, asserted by initiator when we wish to send a message. RST, that is a reset, causes all device controls to disconnect from the bus, and sometimes their start update also. So there are important phases of will be happening. Arbitration in the SCSI mechanism. Controller requests the bus by declaring the bus BG and by asserting its associated data lines. When bus BG become active, all controllers are requesting the bus examine the data lines. Selection will be there. So the controller that wants the arbitration select the target by setting select and data lines of the target. After initiator release the bus BG signal. The target responds by asserting bus BG signal. So target will be reply by declaring the bus BG signal. Target controller will have control on the bus from them. So bus from them. So the from them. So information transfer it will be handshaking signals used to between the initiator and target. So handshaking, you know that initiated the operation, and those devices are ready, then it will be going back to providing a data ready. That is a smooth communication. It is a commitment from both sides has to be follow the protocols. So that is at the end of the target release by bus busy line, there is a reselection will be there. So here we can see that reselection will be happening. That is a DB2, that is a device 2, DB3 device 5, DB6 device 6. So in this 3 devices are competing for this win bit. So arbitration and selection on the SCSI bus, device 6 wins the arbitration, but wins the session, but selected the device 2. So that will be bus BG signal will be there, and select, that is before this clock pulse the buses are free. This time will be spent for arbitration. At the end of this the selection is over. So during that time particular device going to be enjoy that service. So after discussing the PCI and SCSI, so one more expansion bus from the several industry called universal serial bus. So that is the most popular is a USB, is a industry standard made via joint effort of this Microsoft, Nortel, Network, Philips, Compaq, right, HP, and all those they are involved to make a standardized this universal serial bus like PCI and SCSI and ISA from IBM, right. So these people made it a big effort to for the benefit of the users. So the picture we have, you can see that this end will be plugged into towards the system. So that is a metal body, USB metal head will be there. 1 second, there is a miscellaneous components will be there, and USB controller circuit board will be there. So there is a quartz resonator, flash chip on the side of the PCB will be there. This skeleton diagram will can make to understand the USB the body or USB structure of the what we are giving, that is. So there are different speeds of the USB will be there. There is low speed 1.5 MB per transfer of data from the USB to the memory or processor, so on, that is. Full speed will be 12 Mbps and high speed will be 480 Mbps per second, that is. So there is a port limitation will be there, port limitation. So device characteristics also going to be considered, that is a plug and play, of course, that is. So the USB tree structure we can have, that is we can follow here host computer, the computer will be there. So then host computer have a root hub will be connected to another hub. So this hub will be connected to another the root hub will be connected to another hub. So this hub will be connected to this hub. So like this we can have several levels. So the at the end we can have device will be connected to this hub. So we have devices connected to this hub. So like this the devices are connected to these hubs, right? This is a USB tree structure. So coming to this to house a large number of device to add or remove at any time, the USB has the tree structure. So you can add or delete those device. So USB will follow this tree structure. Each node of the tree has a device called hub, which act as an intermediate control point between the host and the IO devices, host computer and IO devices. At the root of the tree, root hub connects the entire tree to the computer, host computer. Root will be connected to the host computer. The leaves of these are IO devices being served as a keyboard, internet, maybe speaker, TV, maybe microphone, or maybe mouse. So several devices connected to at the leaves level. So at root level we have the processor, that is a host computer. So normal operation, a hub copies the message it receives from its upstream connection to all its downstream ports. So normal operation from processor to all other devices. As a result, message sent by the host PC is broadcast to all devices, but only address device will be respond to message. Several devices are there in the motherboard or in the premise of the CPU. Only the identified device will be respond back. However, message from an IO device is sent only upstream towards the root of the tree and not seen by the other device. So there is assume that there is a 5 devices are connected to that root. At leaves level 5 devices are there. Particular for example 4th device want to send some information to the upstream or to the root level. The other remaining 4 devices may not know that, right? So that will be hidden. So at from lower to higher there is some hiding mechanism will be there. So if you want to that processor want to send the data, so that will be sent to particular device by identifying its address. So there also identify the secrecy and all those. So hence USB enable the host to link with the IO devices, but it does not enable these devices to link with each other. So USB enables the host link with IO devices. So addressing mechanism will be there. When USB is connected to host computer, root hub is attached to the processor bus, where it appears single device that is. So root hub attached to the processor, where it appears the single device. So host software links with the single device attached to the USB by sending a packets of information which the root hub forwards to the right device in the USB stream. So it will forward the data to the right device. So each device on the USB, whether it is a hub or device, assign the 7-bit unique address. 7-bit unique address will be there to identify those devices. This is local to USB tree and is not related to any way to address used in the processor bus. So the ID is given from the root hub, so that is only local to that. It even may not know to the processor. So a hub may have number of devices or other hubs connected to it also. As we see in the tree structure earlier, hub connected to the hub, so like that. So device connected to the hub. So addresses are given arbitrarily. When the device is first linked to the hub, when it powered on, it has a 0 address. So from left to right you can take the first device towards the left side, that become the first device. The last device towards the right side, rightmost, that is become a last device. The address will be there. So the hardware of the hub to be which device is linked to capability of detect the device has been connected. So it records the facts as a part of its own status information. As you think it is a own information, so that will be records. So periodically the host polls each hub to collect status information. So each hub will collect the status information, post the host polls. Host will be intentionally ask everybody, all the hubs it will ask whether you have by polling mechanism, asking everybody. That is a polling mechanism. By polling mechanism it will collect the information, learns about how new devices may have been added or delete. So which device we need to be add, because a long time some devices are not used, so it can delete. Or in the converse, some device you have, we can add them. So we can, when you plug the USB into your system, so that will be going to in some particular tree structure, that is a removable disk, as we experience when you plug the USB to your system. So that will be create some instant ID for that. When the host is informed, new device is linked. So it uses sequence of commands to send a reset signal on the corresponding hub port. Port is the physical device which can interfacing. So interface or establish the connection. So read information from the device about its capability, send configuration information to the device, and assign the device to whole USB address. So sole USB address will be assigned to that. So once the sequence is completed, device begin a normal operation and respond to only to the new addresses. So that addition of this device going to be this procedure. So it is done by the guidance of the processor. So protocol is there. So all information moved from USB recognized in a packets, where the packet consists of one or more bytes of information. There is a several type of packets, do variety of control functions will be there. So information shifted on the USB can be split into two categories. One, that is a control and data. So control packets information is that configuration, device initiation, transfer, admitting that data have been received correctly or indicating an error. So that will be control information. So data packets carry information that is delivered to the pre-decided device, that is a target device. Packet consists of one or more fields having a different kinds of information. The first field of an packet is identified, that is a PID, which identifies the type of that packet. So PID, processor ID for that packet. So there are spread twice. First time they are sent with true values. Second time will be sent the complement of it. So the first time it will send the 1, second time it will be sent the 0. First time it will be sent the 25, the second time will be sent the 25, complement of 25. So like that real and complement data will be sent, that is. So 4-bit ID will be there, PID, for identify the one of 16 many packets types. Some control packets such as acknowledgement, during handshaking signals we have to have a proper communication, acknowledgement has to be received, consist only one of the PID byte. So the USB packet format will be there. Control packets used for the controlling the data transfer operation are taken a packet. So there is a first bit will be say that is normal data. So second 4-bit will be a complement of data. So PID 0 to PID 3 is a normal data, and this is a complement. If PID 0 to 3 is a all is 0, then PID 0 to 2 3 is a 1. Complement of 0 is 1. So vice versa. If it is a 1, this become complement will be 0. So the such way that will send the packet identifier field. Similarly, we have token packet in and out. Token packet, that is a PID will be there, and address will be there, end of packet will be there, and checking the data, that is CRC is a cyclic redundancy check, 16-bit. So that is a kind of mechanism they will employ at the destination. After receiving that, the data has to be received properly or not, they have to check it. So several mechanism will be there that will going to be studied in further in depth in network computer networks, right? So that is a one CRC. So packet token packet and in and out will be there. So then we have, that is a data packet will be there, PID and complete, that is a 8992 bytes will be there. So CRC check will be there. So this is the data packet, token packet, and packet identifier field. So this kind of all this information will be required to perform that USB, and output transfer will be there. So there is a host, hub, IO devices. So how the sequence of operation will be happening, that is according to the time. So the x-axis will be hub and y-axis will be time will be there. So the token will be sent, that is a data 0 will be sent. It reach the hub. From the hub we will get acknowledgement, and further it will go to the corresponding device. The same token sent to the device. From the device will get acknowledgement, so it will be there in the hub. So the now this operation is completed. So next host is ready to send the next packet. So token data 1 will be sent. So for which hub will give an acknowledgement. So one more, that is called isochronous traffic on the USB. So key aim of this USB is to carry the transfer of isochronous data. So device that receives the isochronous data require time refers to control the sampling process. So to offer a reference, transmission over USB is split into frames of equal length. The one frame per 1 millisecond long for low and full speed data. So the root hub will be created. So root hub will be start the frame control packet precisely once every 1 millisecond mark it on the start of the new frame. So that is a SOF frame control packets. That will be for every 1 millisecond will be created. Arrival of SOF packets at any device forms a regular clock signal that device can use for one purpose. So assist device to help the device may need a longer periods of time. So SOF packet and carries 11-bit frame number. So following SOF packet, the host carries the carry out input and output transfer for isochronous devices. This means that each device get a chance of transfer for every 1 millisecond. For every 1 millisecond, this device will get a chance to transmit. The isochronous and versus asynchronous. Isochronous can be contexted with the asynchronous, which refers to process in which data streams can be broken into random intervals. So random intervals will be there for the splitting of the data. Synchronous process in which data streams deliver only at specific intervals. So uniform intervals will be there. Isochronous service is not a rigid as synchronous service. So but not lenient or very easier or very simple as a asynchronous service in terms of the security. So it is not as lenient compared to the asynchronous service. So there are also additional electrical characteristics will be there. So cable used for USB connection consists of 4 wires. So 2 wires for power supply and ground. The other 2 will be device may be powered directly from the bus. It may have its own external power communication. The other 2 will be used for carry data. So different signal mechanism will be there used for different speed of transmission. Depends upon the speed they use the mechanism. At low speed 1 and 0 are transmitted by sending a high voltage state 5 volt on one or other 0 the 2 signals wires. So for high speed links differential transmission is employed or device. So with help of this I hope we have discussed the concept, that is as a part of the expansion of the bus, maybe memory bus or processor bus expansion bus. So that is PCI, SCSI and USB. We have discussed in length. I hope you followed. Thank you for patient listening the topic of as a part of the input output organization, that is expansion bus, PCI, SCSI and USB. And the reference book is Carl Hemachar and et al. That is a computer organization, Tata McGrail publication, William Stalling computer organization and architecture by Pearson Education, and many other books are there. Thank you for coordinator and subject expert. So who watch this video lecture, if you have any query, post the query to this mail ID. Thank you once again.